Good afternoon. So I know it's the end of the conference. It's been a long week. Hopefully you've all seen some really exciting things. One of the things I like about software is it's never boring. There are lots of things it can be, but it's never boring. So a bit about me. My name's Aid Miller. I'm a principal program minion for the LINQ to HPC team. At least some of you are awake. Prior to that, I wrote a couple of books on parallel programming for .NET and C++. I'm now working on this very fine thing called LINQ to HPC, and I'm going to talk to you a little bit about that today. So really this is for people who would like to build applications that analyze big data. We'll come a little bit to what I mean by big data in a second. And also for people who are building apps either running on-premise or in the cloud. So I'll be covering both deploying on Azure and showing you deployment onto an on-premise cluster today. We're really going to run through, well, what do I think we mean by big data? Bit of an introduction into what LINQ to HPC is and how it fits into what we're delivering in the next in the next HPC pack. I've got a bunch of demos for you because I knew by this point you'd be bored rigid by slide decks. And a few conclusions and hopefully a little bit of time for Q&A at the end. Although I will be hanging out here afterwards if you have other questions and want to chat to me. And hopefully you'll leave with a general understanding of how big data is processed, specifically how that applies to LINQ to HPC, and some really good examples of what you can actually do with that, with things that hopefully resonate with you in the real world. So what do I mean by big data? This can mean a lot of things to a lot of different people. So hands up if you've got a petabyte or more of data that you're trying to process. Anybody? Terabytes? Tens of terabytes? Okay, right. So it means a lot of things to a lot of people. Some people think it means petabytes. In a lot of cases, we see people doing sort of terabyte workloads with it. It's really being driven by the enormous volumes of data that people are starting to collect today. And typically that data is not the sort of data that your grandfather or your father thought of, which was sort of sales order data, customer data, which tends to grow relatively slowly, right? I mean, yes, someone like Facebook can end up with 1 million or 1 billion customers overnight, but most of us are processing sales and customer data relatively slowly. The difference is we're getting all this other data which tends to be unstructured. So data from sensors, data from all these mobile devices we have now, video data, data from social networking feeds. And there are other industries that just are generating that much more data. I was talking to someone from the oil and gas industry a while back, and the way he measures data is in pallet loads. He doesn't even bother talking about petabytes. It's how many pallets did he helicopter off the oil rig when he was doing his test drills, right? There's just enormous volumes of data. And traditionally, a lot of that was just archived or thrown away. But the sort of commodities of scale that we're getting now with hardware means that you can actually do something with that data and try and extract meaningful things from it that have business value. The other way I like to think about it isn't just in terms of the data, but in terms of how it reduces what I call your time to insight, right? So typically, people are trying to ask these ad hoc questions of poorly understood data. So by that I mean, if you tell me that if I was your business analyst and I was trying to load the data you were giving me into a traditional data analytics package, and I would ask you things like, well, what does your data look like? In the big data space, the answer tends to be, well, I kind of don't know. And then, as an analyst, I might say, well, what sort of queries do you want to run on it? Well, again, the answer is, I kind of don't know. I don't really know what I'm looking for until I see it. I want to run these very unstructured queries on this big mass of data. So the example I came up with the other day was if you have a library, right, and you decide in your library you want to figure out all the books that mention a particular author. I might take all those books, they're all indexed by the duodecimal system. I've invested a great deal of time in ordering those books. I can look for all the authors. I can then use a citation index to find out who's cited who, right? I've had to invest a great deal of time up front in creating those indexes in order to get that answer, right? And that's typically a sort of a traditional database approach. The analogy to that with for unstructured big data sets is someone just turned up on my doorstep and dumped a truckload of books in my front yard and said, ask me the same question. Who are all the authors in these that are ever mentioned in any of these books, whether they're the author or whether they're just referenced in the book? And the solution now is I go and hire a whole bunch of interns, I use a cheap commodity, and I have them just go read all the books in parallel. So I have 100 of them. They all just sit on my front lawn and do it, and they give me the answer. And I may kind of decide at the end of the day I wasn't really that interested in that answer, but I haven't invested a lot in getting that answer, right? Whereas before, I kind of had to know up front that that was something I was interested in. So how do these solutions typically work? So what I'm going to say for the next couple of slides really applies to a broad range of these big data solutions, not just linked to HPC. So really the first thing that happens is I take my data and I distribute it across a whole bunch of commodity hardware. Someone from marketing gave me some pretty animations and I thought I'd use them, so here we go. So all this data gets pushed onto the servers. These are commodity servers, so typically I replicate my data in case I lose a server. I get more data, I just add another one and I replicate my data onto that. Right? So typically you'll see people with hundreds or maybe even thousands of these servers sitting there in racks with all this data replicated across them. So that gives me my 100 terabytes, petabyte of data, what have you. Now I move the code to the data. And this seems like a kind of an easy thing to say now, but it obviously took people a while to come to this realization. So instead of moving a petabyte of data onto the machine with all the code on, I'm going to move less than a megabyte of code onto all my machines with the data. So I compile my code, I move it onto my machines, I run my query in parallel, I try to enforce what we call data locality, which means that I want a particular piece of code running on a machine that has that data local to it. If at all possible, I want to avoid having the code having to look at data that's not on that machine, because now I'm going across the network and I'm incurring a hit there. Really, I want it streaming it off the local disk. And it spits out a result. And that's pretty much the approach that many of these systems take today. And indeed, that's the approach that LINQ to HPC takes too. So we're going to use commodity hardware with all that that entails, and we're going to try and efficiently keep our code right next to our data. And what I'm going to show you with LINQ to HPC is we do all this largely for you. As you'll see, one of the challenges with demoing this is it all seems rather too simple. So, what's LINQ to HPC? LINQ to HPC is part of our complete solution for computer and data-intensive processing. Prior to this release, we basically had an MPI stack, which was largely for tightly coupled compute-bound jobs, right? So typically your car crash simulations. If any of you were in Greg Burgess's talk earlier, he showed some really cool sort of car crash simulations that Wenming produced. Or loosely coupled CPU-bound calculations, which are typically sort of in the SOA realm for things like financial product pricing. So you do Monte Carlo simulations across lots and lots of machines in parallel, come up with a risk model. What we're adding is a data-focused set of solutions. And this is what LINQ to HPC covers. So typically in these solutions, you are not CPU-bound. Typically, you're data-bound. So instead of parallelizing in terms of adding more cores or more compute nodes, what we're really trying to add is more disk spindles. Right? So you have lots and lots of compute nodes with lots and lots of disk on them. And the idea is you scale out that way. So really what we've added to the existing product comes in three different pieces. So here's what we have today. You can see we have tooling in the form of Visual Studio. We have distributed runtimes in the form of MPI and SOA. We have a whole bunch of HPC provisioning infrastructure that I'll show you a bit of today. And then we have two platforms, Windows Server and Azure. And I'm going to show you both of those too. So what we've added is a third runtime. We've added a LINQ to HPC runtime. And I'll be drilling into exactly what that does for us in the next part of the talk. We've added a LINQ to HPC provider. So this is what your code runs against. And just like any other LINQ provider, it provides a LINQ-based front end that allows you to run these distributed queries. And then the other piece we've added is a thing we call the Distributed Storage Catalog, or DSC. DSC is really the piece that manages how your data is distributed across your cluster, right? So it's the kind of the file cataloging piece. It controls replication. It deals with node failure. It deals with balancing data across your nodes. And it works in concert with the runtime in order to get that data locality that we said was so important. So those are the three new pieces we've added, and I'm going to be drilling into those in a bit more detail. So how does the distributed storage catalog work? And we'll be seeing this in one of the demos in a little bit. So essentially, I have an application or a command line, and I'm going to create a new DSC file set. And all a DSC file set is a collection of files, right? So I'm actually going to point it at a directory, say, on my local disk and say, I would like you to turn all these files into a file set in DSC. So basically, all the application does is it asks DSC for a series of write paths on shares on my cluster. So interestingly, I can actually directly get at files stored in DSC because they're exposed on NTFS file shares. So basically, I'm going to go through and I'm just going to keep adding all these files until I'm done, until I have a complete file set. Then I'm going to do what's called seal the file set. So what I'm going to do is I'm going to basically tell DSC I'm done with it. I've added all the files that I'm going to add. And at that point, we seal the file set. It becomes read-only, right? There are good reasons for having read-only file sets. It makes the headaches of implementing a replicated, distributed file store much easier. Once I've sealed it, DSC can come in and replicate it. So it's going to replicate it across nodes. It does this for two reasons. It does this because that means if I lose an individual node, I don't lose all the copies of my data, so I can still keep running. Remember, we're running on commodity hardware. This is something that actually will happen. And the second reason is it gives me some flexibility in terms of moving my compute to my data. I now have more options for where that data is when I want to run compute on it. So that's basically how DSC works. So how do I run a query on that data set? I've got all my data, it's spread across all my nodes, everything's good. Now I want to run a query. So let's just take a quick look at the code we have here, and we'll be digging into this later. You don't have to kind of really follow the exact syntax at the moment. I'll be digging into some of that. But you will notice it pretty much looks like LINQ code. Right? There's really not a lot of difference here. You'll see that first little line that says context from DSC. Right? All that's really doing is hooking my query up to my HPC cluster. And we'll see that in more detail. All right? So the first thing I do is a read and compute operation. So I say from DSC, and I read this file set called logs. Right? Across all my nodes, I start reading different chunks of my file set. And I'm going to do some computation on it. I'm actually going to remove all the lines in my log file that start with the pound sign, because they're comment lines. They're not lines that actually count as log lines. What I'm trying to do here is filter out and get a top set of rankings of pages I like, that Aid likes, within this weblog file. So the next thing I do is do just that. I'm going to take all the requests that end with Aid, right? So again, this is embarrassingly parallel. I take an input, I filter it, I create a new output. Where it gets interesting is when I do something like this, all right? Now I want to group by. I want to cluster everything by the pages to get the rankings, right? So I'm going to group everything by page, and that involves a whole load of shuffling to go on between different nodes, right? I'm creating a completely new data set. And again, we'll see how LINQ to HPC kind of handles this for you. You'll notice there's none of that in the query. The query just looks like any other LINQ query in a lot of respects. And then finally, I do another set of ordering where I'm going to remove going to only take the pages that end with .htm, and then I'm going to order them by descending, so I get the top list. And then I'm going to push that final result out into another distributed file set, which again will be replicated across my cluster, right? And therefore resilient to failure. And this is pretty typical of how you can think about LINQ to HPC. For the computer scientists amongst you, really what we're doing here is executing a directed acyclic graph, where the green vertices represent doing some compute work, and the edges represent either moving files to the same machine or moving files across machine, right? And the trick here is to try and do as much optimization as possible to maintain data locality and not move data across nodes if you don't need to. So that was the theoretical computer science directed acyclic graph version. This is the much more nuts and bolts, how did it actually work on the ground version. So my application runs that LINQ to HPC query. That context that I passed in tells the LINQ to HPC provider on the client where to talk to the head node of my cluster. And I submit a job just like you would submit any other HPC job to the cluster and the head node. You'll notice on the head node I've got another little disk symbol there. That's my DSC database, right? So just like the scheduler HPC database, it's a SQL database. And this thing is the thing that's tracking where all my data is. The scheduler starts the LINQ to HPC job, right? And it basically starts one task, which is the graph manager, at which point the scheduler kind of the HPC scheduler gets out of the way, and the graph manager controls what's going on with that LINQ to HPC job. And the graph manager's job is to maintain data locality and deal with things like node failure. So the first thing the graph manager does is it spins up a whole load of tasks that run these things called vertex hosts across the rest of the nodes it was allocated. And then it starts pushing out work to vertices, and it does this in concert with the DSC to make sure we maintain data locality, right? And it will do all sorts of interesting things we'll come to later, like retry jobs or retry tasks where nodes fail. It will also do what we call speculative execution. So if it sees a particular node seems to have taken an awful lot of time to do some work that a similar node seemed to have done very quickly, it will actually kind of go, well, maybe that node has died. And I've got some free nodes now. I will re-execute the particular piece of work that node did on another node, right? It's pretty smart about this sort of thing. And because of the way the graph is declared, I can actually do that and know that I have no side effects, right? Typically, the problem with doing this in parallel programming is you don't have the guarantees about being side effect free. But because of the declarative nature of LINQ, we can do this. We can actually do some more sophisticated things than this, but I won't go into details of that right now. And then finally, these vertices are spinning up, reading and writing local files, maybe writing non-local files, but only where they have to. Right, so as I said, you've all been here a long time. It's time for some demos. So what I wanted to start with was just hello world. And it turns out that my hello world for LINQ to HPC is join. Sorry, it's not join, it's sort. So I'm going to spin up this little app here. I'm going to generate some data for my sort. And for those of you, have any of you seen the HPC management console? Right, so the other cool thing that we give you with LINQ to HPC is it's another part of the HPC pack. So it's completely integrated into all the cool management features you had if you were running MPI jobs or if you were running SOA jobs on your HPC cluster. So for instance, you can look at, as a system admin, you can look at the jobs that are running, you can look at the jobs that have finished. I can look inside this generate data job and look at the tasks that ran, and you'll see it ran. I'm running this on a cluster in Redmond. It's my little development cluster that keeps my office warm in the winter. It only has 5 nodes, right? For those of you who worry about scale, we're very happy telling people you should run this on up to 256. We've actually tested on larger numbers than that, but just like Ferrari, you know, they tend to tell you how fast they'd like you to drive their car, not actually how fast it will go before maybe you run into trouble. So I'm going to run that app. It's created some data. And now I'm going to start to sort it. And that's going to create another job on the cluster. You see, you can see it sorting data here. Now, what does the code for that look like? Don't do that. This is the code. That's all there is. One of my big challenges with demoing LINQ to HPC is really you get to show one line, right? All I've done is I've created this context. If you look at what the context is, all it is a new LINQ to HPC configuration that I've passed in the name of my head node. Can everyone read that okay? Right? So that's all I've really had to pass it. There are a bunch of optional flags you can pass it, but that's really the only thing it needs to know. And then all I really do is I say I'm going to take my input file set from DSC. It's of type line record, so essentially it's just ASCII text. I'm going to call order by on it, and this is just a standard iQueryable implementation. We haven't done, you know, anything particularly funky here. And then I'm going to push the result back into DSC. And I've actually already got my result back here. This sample was built to show how to do something that used to be called, well, it's one of the sorting benchmarks. And the sort of weird sortable format you see here is the format that uses. But what's interesting is I was also able to provide my own custom comparer because that particular benchmark suggests that you only compare the first 10 characters of a string. And then the other thing I can do is I can grab the results, which is what you saw here. And all I'm doing there is I'm running another job. I'm saying get my sorted data. I already ordered it. It's already sorted. So there's a hint that I can give to LINQ to HPC to say, hey, you don't have to sort this again. Right? That makes it much faster. I don't have to sort it again. I don't have to search for those first 30 records. I know they're going to be at the beginning, right? And then I'm just going to use another piece of LINQ to take the first 30, and then I'm going to write them out to the screen, right? That's Hello World in LINQ to HPC. Is everyone kind of following this thus far? I know there's kind of a lot of moving parts here. When I first joined the team, it was kind of brain overload for a long while. So really what I want to convey here is if you know LINQ to HPC is not a huge conceptual leap, right? There's a lot of stuff going on under the hood, but most of it is abstracted away from you. More to the point, we do it in such a way that you can think about your data and your query, not the underlying implementation, right? You could quite easily take this and stub it out and turn it into a LINQ to SQL query, and it would just do the same thing. The cool thing is here, you can add all your own custom, like I had a custom comparer. Actually, I can execute arbitrary code in there, because under the hood, that comparer gets serialized, right? If you look at the comparer, it's in a little class marked serializable. That will actually, all that code gets moved onto the cluster and run. So I can run any code I like on that cluster. There are some provisos, but essentially I can run any .NET code I like. And most of the provisos are actually for performance reasons, not that, you know, they're things that we have suggested you don't do for performance reasons rather than things that we just don't enable you to do. So another example. Obviously Azure, very important. We're actively working on getting all our features working on Azure. I actually want to show you Azure today. So earlier, because actually I'm kind of getting bored with my office getting hot in the summer. It's great when that cluster warms it in the winter. And then the admin said it was sort of a fire hazard to put 32 machines in my office. Although that would have been nice and toasty, wouldn't it? So what I've done is I've built a cluster in Azure. Took me, 10 minutes to spin it up. That has 32 nodes and a head node. And I'm just going to remote access desktop into the head node. Oh, is it not switched? No. We good now? Yes. So I've remote accessed into the head node. You can see there are my 32 worker roles for those of you who might think I was being underhand there. So what I'm going to do now is I've got all this weblog data. I've got a big web property. It's sitting up in Azure. I'd like to analyze all that data, just like I showed you in that first sort of presentation. So what am I going to do? Well, I'm going to use the DSC directly. So I'm going to say DSC file set list. Whoops. So that's just showing me what my file sets look like at the moment. And what I'm going to do is I'm going to add a new file set. In fact, let's do this. So I'm going to add all the files in this log data directory. And basically, this is sort of pretty typical. You've got a log file for every hour of the day for a few days. And I'll be honest here, these are small log files because we didn't want to be here all week just sort of waiting to process data and waiting for files to upload. So I've loaded all those files and they're now in DSC. And I can actually go look at them. So I can say DSC file set, view, log data. And it'll tell me a little bit about my file set. We actually support compressed files, so typically if you were doing this with web logs, you'd create the web logs, you'd compress them, we'd let you load in compressed logs directly. And you can see that I've got a file set there, and you can actually list the files in it. And then you can go in and you can actually list the individual file. So I can take one of these, list it. You see it probably hasn't been replicated yet. Replication kicks in every 60 seconds. But you can see it's sitting on a share on CN027, right at the bottom there. Ah, and there it is. So now it's replicated. And you'll see I've got 3 copies of that file, right? And I could actually go and access those directly should I want to. They're just on a file share. DSC sort of magically under the hood makes all this stuff come together. So now what I'm going to do is I'm going to run my web analytics app. And what this is going to do is it's going to basically just do the obvious thing you do with logfile and try and come up with traffic per hour, averaged over a few days. And again, I can see that in the HPC Job Manager. The other thing I can do is, and this is the first time we've shown this tool. So We had a tool that was built by the MSR guys. If you didn't know, LINQ to HPC comes out of a project from MSR called Dryad. Dryad was actually a project that's been used not only by MSR for doing a whole bunch of interesting things, it's also been used, the same code base has been used quite heavily within MSN for analyzing a lot of data from web properties, for example. So one of the things to bear in mind is that while we're shipping the first version of this to you guys in SP3, it's actually been around a long while. It's been used quite a bit inside Microsoft. We've ironed out a lot of the sort of issues by actually testing it on very, very large data sets at very, very high scale. But what I can do with this tool is I can take one of these jobs and I can actually look at the query graph, or the graph that got generated, assuming this is going to play ball. Which it is not. Let's just restart this. So again, I'm going to hook this up to my test cluster. Nope, that's not going to play ball. I will show you it on my other cluster. So I can now process all that data in parallel across a whole bunch of machines and just process my log files on Azure without having to move them anywhere else. So that's a great example of why you would use Azure to do this, right? You're generating data in Azure. And there are many examples of people who are doing that today with their apps in Azure. There are other scenarios where you may decide that you want to move data up to Azure. Obviously, you have to do that in a way that satisfies some of the bandwidth requirements. But obviously, over time, things are only going to improve there. So what did that query look like, right? You can do complex queries in HPC. What does that look like in this particular case? So here's the query I'm executing on that cluster. And above it, there's the equivalent query I would execute if I'd just written LINQ, right? They're pretty much exactly the same except for the from DSC and the context, right? I'm going to do exactly what I was doing in the graph slide I showed you. I'm going to do some ordering and some grouping, and then I'm going to return the result. And again, you can see it's pretty easy. I can use all the types. I could actually have used an anonymous type in here. I can have arbitrary functions in here. I can put lambda expressions right into there. I can also provide hints about what those functions, how those functions should be distributed, whether they can be aggregated and what have you. So we've tried to provide you with something that's very powerful, but also very easy to use. And if we go back to Azure, you can see that I've got this little ASCII graph coming out here. What I could do is I could then import that into Excel, right? It's just produced a text file in CSV format and then displayed it like this. So the next example I'd like to show you is a finance example. So is anyone here in the finance industry? Does financial modeling and all that sort of good stuff? Excellent, a few of you. So hopefully this will give you a flavor for what's possible. I'm not a financial expert, so you'll have to forgive me for not not being an expert on some of the actual modeling that's going on here. So this is our financial modeling app for acceleration of back-testing algorithms. So for those of you not in the know, what I'm trying to do here is I have written a financial model, and I would like to back-test it against previous data. So I've loaded onto my cluster, I've loaded, gigabytes of back data for all these stocks. So I can pick one of these stocks. Here I can go into the NYSE stocks, and I can pick, let's pick that one. I've got all this stock data dating back to, from 2008 to 2002 of all the stock prices. And what I'm going to do is I'm going to apply this algorithm to it. And what the algorithm does is it calculates slow and fast-moving averages for these stocks, and then looks for points where the slow and fast-moving averages cross. The reason it does that is because I can actually make money by exploiting that fact. And really what I want to do is I want to run it on all these stocks and see, well, am I actually going to come out? If I'd been playing this strategy for the last decade, say, would I have made money on it? And I want to run it on as many stocks as possible. So let's come out of here, and let's pick all of them. And then let's run it. And we're going to run it locally to start with. And you'll see that I'm doing this on a minute-by-minute basis. See, I'm selecting minutes here. So I'm going to be crunching a lot of data, right? And I'm going to be dragging all this data off of disk on my laptop in order to do that, right? So I'm probably going to thrash the laptop disk. But I'm not really doing that much computation. I'm doing some averaging, but it's not that huge. So let's run that and see what happens. I'm not going to make you wait through all this. The point is it takes quite a long time. My brother actually works in finance, and he tells me that most people in finance don't like waiting a long time to get answers to this sort of thing. So we'll kill that. We will if my mouse would wake up. We'll cancel that job. But you can see from the job history, if I go down here, what if this were? You probably can't see, and my mouse has decided to stop zooming. But you'll see it actually takes 4 minutes, 26 seconds to run on my laptop. And I'd like to do a lot better than that. So what I'm going to do is I'm going to do the same thing again, and I'm going to run it on my cluster. Right? So I've already loaded all the data on the cluster using DSC. It's all sitting up there. All I got to do is run on the cluster. So let's start that going. Now, the interesting thing about the query is, again, it's pretty simple. I'm basically calling this calculate double crossover method on all my list of available averages, and then I'm ordering by the profit and loss percent that I get out of it. And we'll see that's still chugging away. While it's running, I'm going to make another attempt at showing you backtesting. There we go. So this gives you some idea of what's going on under the hood here, right? You wrote a LINQ query, a whole bunch of stuff is happening. Essentially, one of these circles represents a stage, so one of those rows in my directed acyclic graph. So it shows me what I've got running. So I've got 32 partitions. So the data is broken up, in this case, into 32 blocks, right? And I'm running those partitions across however many nodes I've got, in this case 5, because I'm running it on my local machine, not on Azure. But I can actually look, I can see what the actual Dryad code that's being run is. I can actually look at the output from the job. And I can, if I'm running this in real time, I can actually see the nodes working. I can also look at it in terms of a dynamic view, which isn't very interesting for this particular job, but what I'll be able to see there is these bars represent the length of time something took to run. So clearly the job manager was running all the time, and then I'm running these two particular stages. So you can see this one here actually is doing the calculation. You can see there it's saying, we have mousage again. You can see I'm calling calculate double crossover. And then if we move up to the next stage, you can see that's merging, sorting, and taking the first 500. So let's see if we can see how fast that actually ran. If we look at the job history, so there was our original one that ran on the locally. It took 4 minutes, 20 seconds. We're now down to 1 minute and 4 seconds, right? Bearing in mind that also includes sending the job all the way from here to Redmond and back. So I might actually do even better than that if I were running across a LAN. So that's another example of how you can use LINQ to HPC to scale out your calculations across large data sets in a completely different vertical. And that was an example of kind of an existing app. I already had an application there. All I had to do was add some more .NET code to it, right? I had it's a WinForms app, but it could have been a WPF app. It could even have been a .NET app targeting the Metro profile, right? And it could be running on a cluster in the back end seamlessly as far as the user was concerned. You'll notice that I was showing the progress window, showing the progress of the job. That's because I can hook into the existing APIs that the HPC scheduler team already expose to monitor job progress, right? So there's a whole bunch of other infrastructure I can hook into there to not only monitor my job using that UI, but also to monitor it programmatically. Or cancel it, for instance. You'll notice there was a cancel button there. I can go cancel jobs. I can even up the priority of jobs, that sort of thing. So I just want to go and look at some other LINQ to HPC queries. So, most of the ones we've seen so far have actually been, relatively straightforward. You can write some very sophisticated queries in LINQ to HPC. And there are a couple I'd like to talk a little bit about. Who here is familiar with MapReduce? Right, MapReduce, enormously popular. We do MapReduce too. I've not shown you MapReduce explicitly here. It turns out we actually ship with a little extension method for doing MapReduce if you want to do MapReduce. And you can see that in code here. This is just like any other MapReduce, right? So basically, I specify a mapper, a selector, and a reducer. And I specify those using expression functions in C#. It's very straightforward. Then I have this little helper method here. So here I'm doing word count, right? So it's a classic histogramming problem. I've got a whole bunch of, the complete works of William Shakespeare and what have you, and I want to count what was Shakespeare's most popular word. And I can do that with a MapReduce. So I start by counting all the words, then I sum them up, and then I reduce it into this pair count list. So that's how you would do it in, if you wanted to do it as MapReduce in LINQ to HPC. That's already actually a lot less code than you would in some other MapReduce frameworks. But the cool thing about LINQ to HPC is I can actually do it in a much more intentional way. So this is the same MapReduce query, but now I've written it in LINQ. Right? I don't have to get my head around, oh, well, I've got a mapper and a selector and a this and a that. I can just write it like I would any other LINQ query, right? So I'm taking all my lines, I'm splitting them by spaces and tabs, I'm grouping all the words in the line, and then I'm creating counts of them, and then I'm ordering by descending. For extra credit, I'm going to take the first 200. Right? It's a very powerful model for doing this sort of analysis. And this is just one example. You know, MapReduce is great for problems that map onto that pattern, but not everything does. For instance, joining two tables in MapReduce, a bit of a headache. In LINQ to HPC, it's just .join, right? You're done. Just like if you were trying to join two tables in SQL, you're done. So that's one thing I definitely want you to sort of take away. We do quite a bit more than just provide another MapReduce framework. The other thing I wanted to show you was PageRank. So PageRank gets talked about quite a lot in terms of MapReduce frameworks, and obviously it's really important for people building things like web crawlers. What I want to show you here is the sort of query that you can write and what actually happens to it under the hood. So I'm going to open up my PageRanker class. And actually this is interesting because it builds up a query well, not recursively. It builds up a query iteratively. So I basically select all my pages. A page for the purposes of this is just a record that contains a list of the links it has to other pages. And then what I'm going to do is I'm going to build on that query by adding my PageRank step to it. You'll also notice this is using the embedded C# LINQ syntax as opposed to using the fluent interface syntax I was using before. You can use both with LINQ to HPC because we're a LINQ provider, right? The language will just pick up on that. But here I'm actually sort of chaining these queries together in order to produce a PageRank. Typically with PageRank, you run it to get the top rank pages, and then you rerun it, and you rerun it, and you're looking for it to converge. And if we look at what that looks like in, is that one? Nope. Be the one that took a long time. You'll see I'm doing all sorts of stuff in here, and I'm running all these things one after the other. So you can create some pretty complex queries that will be distributed across your cluster without you really having to worry about it that much. Another interesting one I'd like to show you is sort. Right? So the interesting thing about sort is, again, we do a whole bunch of stuff for you for free. So typically what you want to do with you think about sort and you think, well, how do I distribute sort? Right? It's actually kind of, you have to think about it a little bit. And people have written lots and lots of books on sorting algorithms. They're actually quite, they require some thought. And what we do here is because you don't want to be sorting all these things on just one node, largely because it would just be too much data. What's actually going on here, and you can see it in the query, is at the top I'm going to load all my data. Then what I'm really doing here is I'm going to call this LINQ sampler. I'm going to sample the data so that I can then range partition it. And this is all being done for you. So the next thing I do down here is I'm going to range partition it. And then finally, having range partitioned it, I'm going to sort all those ranges, right? And then I can fold them all back together because I know when I range partition, I know that everything in the range partition fits within that range but is not necessarily in the right order, right? So that gives me work that each node can do on its own. And then I can have all the nodes go and sort all the stuff in their particular range, and then I can glue all these ranges back together to get my sorted result. The LINQ to HPC query we saw at the beginning that did sorting, you didn't have to know anything about that. It was just going to do it all for you under the hood. It'll distribute it across your nodes. And this tool that we're showing here today will help with that. We're actually going to be shipping this as part of the tool pack that'll come out with SP3 towards the end of this year. We'll be shipping releasing this with LINQ to HPC with SP3 towards the end of the year, and this will come out as a tool pack, so you'll be able to actually drill down into your queries. So there's a whole bunch of stuff that this tool helps you understand. Really what I'm trying to do here is just articulate to you there's kind of a lot going on under the hood. A lot of the time when I do parallel computing talks, the nasty edge cases that often caused us to spend many, many months as a product team trying to figure out how to get something actually working sort of don't manifest themselves. I just want you to understand that we've kind of done a lot of that work, that heavy lifting for you guys so that you can just go write great apps. The other interesting thing about visualizing your queries is it's a way to make sure you're getting the best performance, right? Just like if you were writing, SQL queries, for instance, you tend to want to, go and look at how they're actually being executed. So a couple of conclusions. We're giving you a really powerful programming model. It's, fully glued into Visual Studio, so you can be as productive as you are when you're building other apps in Visual Studio. We're also integrated into the HPC management and a whole load of the other Microsoft infrastructure like Active Directory inside of HPC cluster, so that you can leverage your existing assets and infrastructure. For instance, you could get some of your data out of SQL Server to run against LINQ to HPC queries. And as I said before, it's not just parallel for, right? There's a lot of sophisticated things going on under the hood, like speculative execution, which we talked about, like handling node failure, like replicating your data to make sure that it just works, right? You write your query and it just works. And we collaborate very closely with the guys in Microsoft Research, for instance. One of the nice perks of the job is I get to go talk to those guys, and they're really smart, and you learn a lot from them. They've invested a lot of effort in this over the last 5 years, and are running this on lots of their research projects. So we actually have some of them testing the latest versions of the product on these big data analytics problems that they're interested in. If you want to see Greg Burgess's session on Scheduler and Windows, Azure, and HPC, it was this morning, but obviously it's online. There's a white paper written by David Chappell, which is a really great introduction into LINQ to HPC. You can download the beta 2 of LINQ to HPC from Microsoft Connect. We have a team blog. I sometimes post there. They also have my blog where I sometimes post all sorts of stuff, not just necessarily LINQ to HPC. And we have roughly 5 minutes for questions. I'd ask you, if you have a question, please use the microphone so that people watching later can get to see it. Questions, anyone? Yes, sir, in the yellow shirt.
Have you done any performance analysis in comparison, for example, to the SQL data warehouse or any addition of SQL Server? When does it start to make sense to move your data into HPC as compared to just loading it into a database?
So I think to paraphrase your question, it's really, from a performance perspective and just from a sort of general sense perspective, when should I use parallel data warehouse or, my big SQL instance, when should I use LINQ to HPC? I would say that they're really for very different things, right? One is for dealing with a lot of this data that probably doesn't fit very well into a standard SQL table, right? I'm analyzing a whole load of video streams or just arbitrary text. What I would say is that the sort of thing I see customers asking about doing is they want to use something like LINQ to HPC to make some sort of sense of that data, and then they're going to load the results of that, those LINQ to HPC queries into something like parallel data warehouse. Does that kind of answer your question? Okay, yep. So the question was, well, I was thinking more in terms of size. I believe parallel data warehouse tops out at, is it 400 terabytes? Whereas we will tell you that you can use at least a petabyte in this. But it does very much depend on kind of what you're going to do with the data. Because, for instance, we are not a distributed key value store, right? So we're not like, say, MongoDB or HBase. Right? We're really about doing this sort of analysis, not about being a distributed table store like the things I just mentioned or even Azure tables. Is that a better answer? Excellent. Question, sir?
What's sort of the minimum resources that you would need to use in terms of getting up and running with testing this and trying this and developing, for example?
Good question. So today, while we're obviously working very closely with the Azure guys in order to get things up and running in Azure, today what we have is the beta that's out on premise. Really what you need is 4 machines, right? You can run it on VMs. I've seen people do it. It tends to be kind of slow, right? And, I'm in HPC because I like fast, so, sort of defeats the point. But you can do it for testing purposes. But if you look at most of my group, they have a cluster of 3 or 4 machines sitting in their office. They don't have to be particularly beefy machines. I just have a bunch of, cheap desktop machines. And you can run them up and run HPC pack on them. So it's a relatively small outlay, and we've invested quite heavily in trying to make that sort of initial setup scenario fairly pain-free for you. Provided the machines are connected to a domain so they can do all the authentication, it's pretty straightforward. If you look on the web, you'll find there's actually a couple of documents that will walk you through that. We actually wrote a special one for developers for LINQ to HPC. It's like, I'm a developer, I just want to get this thing set up on my desktop for me. So it has a whole bunch of the stuff cut out of it that you would have if I'm an IT pro and I'm trying to get this set up on 100 machines for my organization. So I'd encourage you to check out the Connect site. That's got all the docs on it. You should be up and running in a morning of doing a bit of reading and poking a few machines. Does that answer the question? Excellent. Any more? Another one over there.
Are compiled queries supported as well?
Sorry, could you say that again?
Compiled queries in LINQ.
Compiled?
Queries.
Queries. So the query, you have, do you mean pre-compiled queries?
Yeah.
Not at the moment, no. So what's happening under the hood, when I sort of click, do the query.submit, what happens under the hood is the code that I'm running gets dynamically compiled. The LINQ to HPC query provider is smart enough to figure out all the dependent DLLs, right? It's also smart enough to figure out that any DLLs that start Microsoft.com or system.something or other are on the machine. You can tweak that so it won't needlessly move stuff. So it takes the compiled code, any dependent assemblies, and a piece of XML that essentially represents the query, pushes that onto the head node. It then gets distributed onto all the other nodes, right? We haven't provided you with a facility to get rid of that compilation step. But typically that's not going to be your bottleneck, right? You can certainly minimize that by moving some of your code into an assembly that's already compiled. But typically your bottleneck is actually running. It's not the compiling of the query.
That wasn't exactly my question. When you compose a query in LINQ, you have two choices, right? You can leave it in its, I don't know what to call this state, like not compiled state. Mm-hmm. And then you can define it as a function where it's where it executes faster because the interpreter doesn't have to recompile it before it executes it. It's a special way of.
So the answer is I don't believe we do.
Okay.
Right. You can kind of get around some of that by. I guess you can put more of your query inside a function. Right, so maybe you can do some of that, but I'm not entirely clear whether we can do that. Maybe we can talk afterwards.
Sure.
And I'll be very happy to give you my email address, and I'll get an answer from the people what wrote the code, which wasn't me. I think I'm out of time, but thank you very, very much for coming and staying till the bitter end and listen to the talk. I'd also like to thank the AV people who never get thanked, and as far as I can make out, it's all gone really smoothly as far as that's concerned, which has been really awesome. But thank you.